41 in 5.1. So from 6x minus 13, we have to subtract, and I need to use parentheses. I have to subtract the existing piece, which is 3x minus 6. This is what I need to do first. And now remember, we have to distribute, and we have to distribute to both terms. Don't pick and choose. I'm not saying you are, but just to make sure. Negative 3x and plus 6. Always arrange polynomials in descending order.
3x.
So we have 3x, yes, minus
7.
minus 7. So that's the missing quantity. Okay, I think we got the idea. I think we understand how to evaluate. Let me know if you want to, this is the same problem, but just two different polynomials. Do you think we can say that section 5.1 is understood? We can move on? Is that a yes? Okay, perfect. So let's continue. Let's move on to 5.2. The most important section or chapter, if you want, in this class is on factoring. So I'm trying to get there and spend as much time as needed. Okay, so let's look at the learning objectives first. Simplify exponential expressions using the product rule. Yes, we're going to do that. Simplify exponential expressions using the power rule. Yes. Simplify exponential expressions containing products. Yes. Multiply monomial by monomial. Yes. So these are very important. Okay. So before we look at any problems, let me explain. If we multiply two first of all, let's again define an exponential notation. An exponential notation has a base, a number, is a number, not a variable, and it has a power. Let's say n. So this is the power. This all together is an exponential notation. It has a base and a power. What can the base be? Any number. The base can be any number. What about the power? It can be any number. The only one that we have to shy away from is something I explained, 0 raised to 0. We have to wait till Calc 1 to discuss this. So we do not talk about base 0 raised to power 0. This is not for our course. Can I raise 0 to any other number? Yes. Can I raise 0 to negative 1? Yes. Any number. This one I cannot. So this is impossible. 0 raised to negative 1 is not possible. 0 raised to the first power is possible, but 0 to negative 1 is not, because we know that division by 0 is called
Inconclusive.
undefined.
Yeah. So I keep saying that.
Yes, it's a fancy word. Yes, I agree. Or it doesn't exist. That's good enough. We prefer undefined, but it doesn't really matter. Okay. So there are a lot of rules. Exponential notation has tons of rules. Okay, here's one that we just talked about today. What was the one we talked about? A to negative n, which is 1 over a to the nth power. This is not mentioned here, is not for today. I just wanted to re-emphasize that we talked about this for a few minutes ago. Okay, good. So now, rules. A base raised to a power. My n has 2 bubbles multiplied by the same base raised to the mth power with 3 bubbles. This is n, this is m. Well, we copy the base and we have to add the exponents, n plus m. So this rule has to be understood going in both directions. What does that mean? This is not important right now, but please understand that if I have this, I can come back to this. If I have this, I can go to this. So here's an example. Now, how will I explain this, or how will you explain this rule to anybody? You will say this. When you multiply two exponential notations having the same base, that's mandatory, having the same base, don't touch the base. Just copy the base. Don't do anything to the base. And add the exponents. Do not touch the base. So 2 to the third times 2 to the fifth. I copy the base, add the exponents, and I get this. This is nice and beautiful. But what we are really interested in is this. Copy the base. Do not multiply the exponents. But this is the product rule. You have to copy the base and add the exponents. Without this, we don't know how to multiply polynomials. So this is our first step towards, remember, we learned how to add polynomials, we learned how to subtract polynomials. We reached now the level in which we want to learn how to multiply polynomials. In order to multiply polynomials, we have to understand these rules. So when we multiply exponential notations having the same base and different exponents, or the same exponent, it doesn't matter, we copy the base. Don't touch x, please. We copy the base and add the exponents. So I copied the base and I added the exponents. So this was the first rule that we needed to review. Now the second rule we need to review is this one. When I have an exponential notation, but this time is all raised to power m. So this one is the product rule, but this is the power rule. Power rule, product rule. Two different things. This, again, I don't touch the base, just copy the base. But this time, we are allowed to multiply the exponents, n times m. What does this mean? Well, as an example, 2 to the third, everything to the fifth power, copy the base, multiply the exponents. So if I want to raise a monomial, let's say 2x squared y to the third, and I want to raise it to the second power. Each and every factor inside the monomial has to be raised to power 2. Here I only had one exponential notation, but here I have 3, and they are all multiplied. 1, 2, 3. This has to be raised to the second power, this has to be raised to the second power, and this has to be raised to the second power. So can anyone get us started with 2 squared?
4.
Times. Copy the base. What do I do with these exponents?
4.
Multiply them. Very good. Copy the base. What do I do to these with these exponents?
6.
Indeed. Of course, I'm not going to write it like this. Condensed is 4x to the fourth, y to the sixth. And it's done. So for now, we looked at the product rule and we looked at the power rule. We also know this rule, and we also know this rule. Rule number 3, a to 0 is 1 as long as a is not 0. So these are the rules that we discussed a long time ago. Very soon we're going to use this rule, which is the quotient rule. When we divide a to the nth power over a to the mth power. It's a different rule. We still copy the base. Don't touch the base. Don't do anything to the base. But this time you have to subtract the exponents. And it's always in this order. From the exponent of the numerator, I have to subtract the exponent of the denominator. You can never change the rule, regardless of the exponents. So here's an example. X to the fourth over x to the second power. I copy the base, and I have to subtract the exponents. And 4 minus 2 is 2. Now we're ready to learn how to multiply. First, let's multiply monomials. Multiply monomials first. And then we'll multiply binomials, trinomials, and so on and so forth. So I'm going to come up with two monomials. Let's say 2x to the third multiplied by 4x squared. So remember the commutative and associative rules. So you can do whatever you want here. You can change the order. They're all factors. 2 times 4 is 8. I copy the base, add the exponents, and I'm done. So that is how I multiply two monomials. So here's another example. Let's say negative 3x squared multiplied by 7x to the fourth. Can anyone give us the answer to this?
Negative 21x6.
X to the sixth power. Very good. Copy the base, add the exponents. Good. Now let's see how we multiply two binomials. Or maybe first I should multiply a monomial times a binomial. Let's do that first. So monomial times binomial. A very simple example. Let's say 2x multiplied by x squared minus 3. So now I distribute 2x to two terms. What should I write?
2x cubed minus 6x.
This is it. That's all. Thank you. That's all we need to do. We distribute 2x to two terms. So 2x to the third minus 6x. Again, you cannot pick and choose. Be careful. Always distribute to all terms inside parentheses. Now, what if I have 2x minus 1 multiplied by 4x minus 2? So this is binomial times a binomial. When we multiply two binomials, we have to distribute either from the left to the right or the right to the left. It doesn't matter. You choose. It really doesn't matter. Here's what I like to do with this problem. I like to distribute 2x to these two. And when I'm done, I like to distribute negative 1 to these two. Is this the only order? No. You dictate the order as long as you multiply all terms as required. Good. 2x times 4x is 8x squared. 2x times negative 2 is minus 4x. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is positive 2. Now I have to combine like terms. Present it in descending order. And that's it. So 8x squared minus 8x and plus 2. How do I multiply? And then we're not going to go beyond that. A binomial times a polynomial. Let's say x minus 2 multiplied by 4x to the fourth minus 3x squared minus 4x and minus 7. Of course, I'm going to start from the left. I'm going to distribute x to these 4 terms. And of course, I'm going to distribute -2 to these 4 terms. So initially, I will get 8 terms. Hopefully, they will collapse into a much condensed form. Remains to be seen. So, x times 4x to the 4th is 4x to the 5th. Copy the base, add the exponents. X times -3x squared is -3x to the 3rd. Copy the base, add the exponents. X times -4x is -4x squared. X times -7 is -7x. -2 times 4x to the 4th. -2 times -3x squared. -2 times -4x. And finally, -2 times -7. Yes, I have to fully simplify it and present it in descending order. Question is, where do I start?
Where it's to the 5th.
Yes, and it's all by itself. I have to copy it. Then I have to look for the next in line, which has to be, that's why I was asking you a silly question. A silly question, if there are any missing terms. Who cares? Who cares there are missing terms? Well, it's important, because only when I understand, if I understand that, then I know how to present it and in descending order. So the next in line has to be power 4. Do we have power 4? Yes, we do. -8x to the 4th. Now I have to look for power 3. Do I have power 3? Yes, only one term. Now, do I have power 2? Yes, I do. These two. 2x squared. Do I have power 1? Yes, I have just these two. Do I have a free term or power 0, degree 0? Yes, I do. Only one term. That is the reason why we need to look at these polynomials and say, oh, degree 5, no term is missing. It has degree 5, it has degree 4, it has degree 3, 2, and 1, and degree 0. The leading term is this, and the leading coefficient is this, degree is 5, and so on and so forth. So yes, nobody cares that, let's say, these 2 terms are missing. But I need to understand how to present the simplified form. And I have to look for the terms and put it in the correct order. Okay, I think we are ready now to look at some of these problems and see what's in here. Good. And this is my page 12.